All right, practice quiz. Problem number 1. State the domain using interval notation. And because of this color coordinated system, where we're all in groups now, I can see who's here from each group. So you don't need to report who's present in your groups anymore.
So you like what I did?
Oh my gosh, that's fabulous. I really like it, Landon. Thank you. All right, let's come back to this. Landon, I'll have you maybe give me a lesson on how you did that so I can institute this in my other classes as well. I like it a lot.
All right, sure thing.
Didn't realize how valuable that was going to be. Okay, 30 seconds more on the domain for problem 1. And let me just check how many are here. Okay, alright, I think we have most everybody here. Alright, so before I get into the answer on this problem, let me talk about if you're struggling and anticipate that at some point in the semester everyone is going to struggle and have a tough time, have a tough section, and let's go over the resources that are available to you when you are struggling. So let me put my screen on here. Let's go into this. When you go into my MATLAB, into Canvas, and when you're in Canvas, you see on the far left, BrainFuse Online Tutoring. Advantage of this tutoring is it's 24 hours, 7 days a week. You can click on this if you're doing your homework at 2 a.m. and it'll hook you up one-on-one with somebody somewhere around the globe, and you'll get some individual assistance there. And I've gotten mixed reviews on this. Some students have really liked it, and some have said, not consistent. Consistently good help. Sometimes they don't understand how their tutors are explaining things. All right. And another option that you all have is if you go to the SFCC website, sfcc.edu, and now if I log into my SFCC, okay, so if we come down here, so there's tutoring center, so schedule an appointment. We see right underneath welcome, schedule an appointment, and then there's tutoring center online. So we still are employing tutors at the community college, and you can select the topic that you need help with, and you can schedule a one-on-one tutoring appointment with an SFCC tutor. So that will really mimic the kind of the tutoring that you might be used to as somebody here at the community college. And okay, and also there's always me, and you can send me an email, and we can set up a time to do and I can give you some help one-on-one as well. Alright, so let's go to this one. The domain, when there's a square root involved, I cannot have negative numbers. I could state this in the negative. X cannot be negative. But let's state it in the positive. X must be greater than or equal to 0. That's normally the case, but it's also the case that this is in the denominator. And we cannot have 0 in the bottom of a fraction. So that eliminates this part. So it's just x greater than 0. And then it asks for it in interval notation. Now, this, I believe we were supposed to get to this last time, and some of the homework said interval, put your answer in interval notation, but we didn't have enough time to go over interval notation. So, let me show you what interval notation is. Suppose you have the interval from 1 to 4. And it's filled in over here and open over here. So this would be the same as x greater than or equal to 1 and less than 4. And in a more compact notation, we get to leave out the x. It's called interval notation. When it includes the endpoint, with a greater than or equal to, you use a bracket. And when it doesn't include the end, you use a parenthesis. And it would be like this, the interval from 1 to 4. What this leaves out is what was the variable. And so you have to know what the variable is from the context. Oh, we're talking about x's here instead of y's. So, but it's everything from 1 to 4, including 1, but not including 4. All right. Now this one, if we look at the picture of this, this is x greater than 0, so it's not including 0, and everything to the right. So the domain on this one would be parentheses in interval notation. Not a bracket because it's not filled in. There's no equal sign there. 0, comma, and then what do you write down if it goes to the right without ever stopping? Go to infinity. And infinity is more of an idea than an actual number, so you never have a bracket around infinity. It's just parentheses right here. So this would be the domain, and this would be the domain in interval notation right here. And give me a little feedback on problem number 1 in Discord. Need practice. I like that. Okay, because if it's something new, it's going to take a while before you really get it. Oh, how do you find the recordings of the class? Great question. Let me show you. If we come back over here to our class. So, go to modules. Very first thing you're going to see in the modules is class videos. And it takes a while for me to upload them into YouTube. So that's why, it's usually a number of hours after the class is done that the video is available. But they'll all be right here, and there's the first two. We've only had 2 classes so far. Okay. let's pop over. Let's go to the next one. State the domain, same directions, using interval notation. Copy those directions. So go ahead and do that. Okay, 30 seconds more. Okay, I'm going to have you stop. So the intention on this is I'm not trying to rush you here. Hopefully, if you're going to get stuck, I've given you enough time though to find out where you get stuck so that it's useful information to you. Alright, so to get the domain, I would look at this and I would say, alright, if x is 5, that's going to cause the top of the fraction to be 0. That's not a problem. Tops of fractions can be 0. The problem is when the bottom of the fraction is 0. But what value of x is going to cause the bottom to be 0? I'd be at first tempted to say, well, x cannot equal 0. But that's not it, because if x is 0, the bottom of the fraction becomes 2. And 2 is just fine. So this is not what I want. I want to see what value of x causes this whole bottom to become 0. I can tell what that is if this is factored. I can't tell it while it's looking like this. But if I just factor it, x times x will return the x squared. Always do the signs next. These two things are going to multiply to be a positive number, so they need to be both positive or both negative. I want them both positive. Now these two have to multiply to be positive 2. 2 and 1 will do the trick. Now notice if I FOILed this out, I would get x squared plus 1x plus 2x plus 2. Or in other words, just the inner and the outer confirm that I'd factored it correctly. And then now in this factored form, instead of looking at it like this, look at it in its factored form. And let me erase this stuff, get rid of the distractions. In its factored form, I can tell what's going to make the denominator 0. If x is negative 2, then that's going to cause this to be 0. 0 times anything is 0. And so x cannot equal negative 2. And x cannot equal negative 1 for this one. So that's the idea of the domain. And this way of stating the domain is usually fine, except if you're told use interval notation. So this one is great practice for us with interval notation. Now let me draw a little picture of a number line. Here's negative 1, here's negative 2. What this is everything over here, everything in between here and here, and everything over here. So you're going to write whatever this interval is in interval notation. You use parentheses or brackets. Whatever this interval, and you're going to put a U for union in between these. And then whatever this interval, and you're going to put another U for, you don't make that O part of the U. Another U for union for this portion. So, let me give you a little bit of time. Make your best guess what this is in interval notation. Fifteen seconds more. Okay, let me show you interval notation for this. Let me do the easy part. From -2 to -1, parentheses on both ends. The next easiest part, from here on out. -1, go forever to infinity. Now, way over here, we say that's positive infinity. Way on this end is negative infinity. But it's more of an idea than a number, so that's why we put parentheses around it. Alright, now, the typical student mistake on this is to write this interval like this. -2 to negative infinity. That is wrong because, let me show you. We always have to have the smaller number on the left, the bigger number on the right. If you'd have written this as -1, -2, from here to here, that would have been wrong. It's got to be left to right. That would have been wrong. And here, left to right. But this one, we're going from right to left. It's kind of natural to do that because the arrow is pointing in that direction. You want to start here and go, but you have to go from left to right. This has got to be negative infinity on the far left up to -2. Union that, union that. All right, everybody give me a little feedback on this one, please. The U's mean union, and it's the equivalent of the word or in mathematics, but we use it in an interval notation between sets. U for union, it's got to be in here, or it's in here, or it's in here.
Can you explain why we have to use two U's in that situation?
Say that again?
Can you explain why we have to use two U's in this situation?
Two U's? Okay. Well, let's come back to it. Alright. When you have three different intervals, in between each of the intervals, you got to have some kind of symbol. So we got this interval way in the far left, the next interval in between them, we're going to put, it's either over here, or it's over here, or it's over here. And we show that with the union symbols. And notice it would be very different if I had tried to use and. A number can't be over here, and at the same time over here, and at the same time over here. If I'd have been using something that meant and, it wouldn't be right. The solution is either over here, or it's here, or it's here, Just one of those cases. Chrissy, does that help?
Yes.
Okay, thanks. All right, let's do the next one. Write the domain and the range in interval notation. Let me copy that once again. I think. State the domain using interval notation. Excuse me. Okay, 15 seconds more. Okay, so on this, I could just try some random numbers. Not totally random, kind of well-chosen random numbers. And if I was like putting 0 in here, I would get square root of -6. We can't do that. And I'm putting numbers all the way up to 5. I'd still get square root of negative numbers. These are not allowed. 5.9, still not allowed. I get a square root of negative number. But when I go to 6, then it works. I get square root of 0, which is 0. And if I go to 7, I get square root of 1, which is 1. And so I can see from here that the domain is x greater than or equal to, it can be equal to 6. All right, but that's not using interval notation. So we need to fix that. So when I fix that, interval notation, it would be 6 to infinity, like this. All right. Now, the other way to do this problem, and I keep showing this because when you get to the really difficult ones, and we won't really get them that difficult in this class, but if you keep going in this math to pre-calculus next semester and then calculus, you'll be having to do this kind of thinking regularly. So I'm introducing this kind of thinking to you now. This whole thing, when I figured out, like if you're plugging in x equals 7, you plug it in and it reduces down to 1. This whole thing must be greater than or equal to 0 because it's inside the square root. And then we solve this. We can get to this domain the same way. On more complicated ones, we make an inequality out of it and we solve the inequality. Okay. And I'm going to skip the feedback on this one. I'm going to jump down to number 1 here. State the domain and the range from this graph. Okay, 30 seconds more. So suppose the input was 10. What's the output? Well, we go here and we look straight up or down, and well, 10 is not a valid input. The domain, it's got to be between, and then we ask ourselves this question. How far left on the x-axis to how far right on the x-axis? And we go from 4 on the x-axis to 8. In interval notation, it would look like this. And for the range, well, you can never get an output of like -6. That doesn't happen. That graph isn't down here. The only outputs possible are from a height of, you ask for the range from how low to how high. It's going from a height of 2, you can't have a height of 2, up to a height of 8, and you could have a height of 8. That's domain and range from a graph. Give me some feedback on this one. It's helpful to get different perspectives on the same thing. Okay, to number 2, same thing, take the domain and the range. Domain and range. Thirty seconds more. Okay, so the domain for the possible inputs. Oh, I can go all the way from -4 to +4. And brackets on each end. What about the range? What are the possible heights? Well, the lowest height is 0. The highest height is 2, and it does look like it touches 2. If there had been something like this with an open circle on the highest point, then we'd have put a parentheses there, saying that you can get infinitely close to that, but you can't actually touch that highest height. Alright, so let's skip the feedback on number 2. Let's go to this one. It's supposed to be that all. See what happens? I forgot to do this. I'm supposed to put a pound sign because notes will renumber my numbers if I don't do that. And let's go over here. This will make sense. Number 3. Right. So this actually, I want you to use this graph up here. So let me erase this direction now. Let me get rid of this. Get a large eraser. Alright. Using that graph, do these 2 parts of this. And we move these up. a little closer. Let's call this AA. I have to do AA or renumber that as well. BB. Alright, so using this graph on the left, find f of 1 and then find all x so that f of x is equal to 1. Thirty seconds more. Alright, maybe stop. So, this 1 is an input. So it goes on the, it's an x, goes on the input axis. So find f of 1 says look at x equal 1, go straight up or straight down, find the height of that point. And that's going to be something like 1.8. It's getting really close to 2. Yeah. So anywhere in there would be fine. And just estimate that. Now, this is saying find all inputs x so that the output, after you take f of that x, you get 1. This is an output. So it's on the y-axis. So you look for 1 on the y-axis and you say, what are the x values that would have had given me a height of 1? Well, you look over here and it's this point, directly below that, which is about 2.9, really close to 3. But there's another one way over here, about negative 2.6 maybe, in between negative 2 and negative 3. Find all x so that this is the case. We're going to get these 2 answers. All right. Give me feedback on this one, please. Brackets and parentheses. So a number of people want more info on brackets and parentheses. Thanks for asking. Right, this last one was trickier than it appeared because the notation is getting used to that. That second one was really an output and not the input. So. Right, let's go back again to, let's practice a couple things here. So you'll get more out of it if you practice it yourself rather than I just repeat myself. So I'm going to give from negative 3 to positive 2. This is the interval. And don't include this point, but do include this point. here to here. Write this interval in interval notation. I'm going to give you 30 seconds. If you're not sure, take a guess. You get more out of it if you adjust an answer rather than just watching and waiting. Alright, so this, we use parentheses when we don't include the endpoint. We use brackets when we do include the endpoint. And it looks like this. Okay. Now, what does that mean in a kind of a more practical sense? Suppose I said, there's a club that lets people into it only if they're greater than or equal to (4 feet) and less than 6 feet. You can only get into this club if you have these dimensions. And because if you're equal to 4 feet, you can get in, we put a bracket. But if you're exactly equal to 6 feet, you can't get in, so we put a parenthesis. These include the endpoint, but these do not. Right here. Inclusion and exclusion. Alright. Should I do another practice one for interval notation before I move on? Let's go to the main text channel. Type in yes if you want to see another practice. Interval notation, maybe with infinity, involving infinity, or one side or the other side. Okay, let's go back. Give you 2 of them. Alright, so and this one. Write that in interval notation. Write that in interval notation. Give you a quick minute. Okay, so this one from left to right, include the endpoint, go all the way, keep going, infinity. This one, we have to go from left to right. I'd be tempted to go 2 to negative infinity, but I have to go negative infinity, up to 2, don't include the endpoint. Okay. Let's go. Alright, we have number 2, number 3, this is number 4, I could renumber them and put them all as number 1. Do this stuff. Put your so solve these 2 inequalities and put your answer in interval notation. 30 seconds more. Okay, first one. Solve it just like an equation. So an interval. It looks like this. Here's 4, and it's everything 4 included, and everything to the left, but in interval notation, it looks like this. From negative infinity all the way to 4. That's my answer. Okay. Yes.
Explain how the signs change. And the signs.
How does the sign change?
Yeah, it only changes when you multiply, or.
Ah, very good. So let's do the next one, and that'll bring that up. Thanks for bringing this up. What's your name?
Nadine?
Nadine? Okay. All right, so let's do this next one.
Wait, Robert.
Yes.
Shouldn't there be a bracket on the 4?
Oh, thank you. So, good catch. All right, let's go to the next one. So I'm going to divide both sides. Now, the sign is going to, we're going to have to turn around that inequality, because it's when you multiply or divide both sides by a negative number. We do exactly, we treat it just like an equal sign, but with this exception. We don't like this. So we divide both sides by a negative, and then the next time we write the inequality, we have to point it in the other direction. So let's go right to interval notation. That's from negative infinity to negative 4, like this. And I'm going to ask you to do, well, actually, I'm just going to do it. I'm going to do it I'm going to get the same answer, but I'm going to do it a different way this time. The first thing I'm going to do is I'm going to add 2x to both sides. And then I'm going to subtract 8 from both sides. And then I'm going to divide by 2 on both sides. And then I'm going to get negative 4 greater than x. But of course, I wouldn't write my answer like that. You have to lead off with the x. And then the arrow's pointing at the x. Notice I'm going to get exactly the same answer. And the reason why we have to, or one of the ways that we can see why you have to reverse the sign when you divide both sides by a negative number, is because if you were avoiding dividing by a negative number, you'd move this to the other side of the inequality. Instead of the arrow pointing away from the x, now the arrow is going to be pointing at the x. And so we got to be aware of that. So give me a little feedback on number 4 of these problems. Interval notation, we just kind of need to get a lot of practice with it. Which we're starting to get some. Alright, now... Alright, we still have some practice quiz problems, but we have run out of time. So what we're going to do is we're going to start again. In 15 minutes at 1:31 p.m. And I'm going to jump over the last couple of practice quiz problems. I'm going to get into the section. We'll do, I'll take a couple questions if there's questions on homework, and then we'll do the section, and if there's time remaining, I'll come back to the rest of the practice quiz problems. I often have more on these OneNotes things than I can get to. And that's not a problem. It's just in case things go quicker than I thought and I could get to more, I put it there. All right. So, does anybody need to talk to me individually before I take my break? All right. I'll see you in a bit.
Check. 1, 2, check.
All right, we're back at it again. And questions on homework. Any questions? Or on anything that you want to ask? And sometimes some good questions are even when you can get something, but you're not 100% sure you really understand what's going on. You want to be sure of your answer. Any of those are good.
Do you have any like shortcuts or recommendations when you're foiling?
Foiling? Yes, I do. Is it like 2 terms times 2 terms? That kind of foiling, like 3x plus 1, or longer?
Well, I guess like to get it into foiling. So like the last problem that we had was like x squared plus what is it, 3x, and then another term.
Like this?
It was x squared plus 3x plus 2. Yeah. So I guess I find myself, I overthink it what I'm trying to foil. So do you have any shortcuts in
Okay.
when when you're trying to FOIL them out?
Okay, so the terminology we would use here would be factor that when we're trying to factor. And when you take something like this and multiply it out, we'd call that FOILing it out. You know, multiply it out. Okay, and so what you're really talking about is this, the factoring, how to do this, right?
Yes.
Okay, so let me give a little brush up on factoring. The most basic factoring is this, 3x squared plus 6x. And then we'd say, all right, what do these two terms have in common? They have a 3 and an x in common. We factor out the common element. What's left is x plus, and then what times this would give you this, or what is 6x divided by 3x? It's 2. So that's factoring. Taking something that's actually two terms and making it into a multiplication problem. All right. Now, when you have three terms like this, at first it doesn't look like you can factor it because there's nothing common to all three. But there's a way to factor it as long as you see this structure. Whatever I put here and here, first thing in each parentheses, has to multiply to be x squared. So we'll balance that out as much as possible. X and x. And then the next thing we'll always do is look at the signs. Common mistake that slows people down is trying to put the numbers in next. Figure out what the signs are. Just like these two had to multiply to be this one, these two have to multiply to be this positive 2. So they have to be both positive or both negative. And then since we're going to get a positive middle term, we want both positive. And then these two numbers have to multiply to be 2, and then we hope that the middle term will turn out to be 3x. And so it has to be 2 and 1 or 1 and 2. It doesn't matter what order we put those in since these both have 1 x's. All right. And then the way you check your work is you FOIL this out. This times this times this, and so on. But I already know that this times this is going to be x squared. I chose it that way. And I already know that 2 times 1 is going to be 2. Those were chosen that way. The only thing I really have to check out is the inner plus the outer. Make sure that they add up to this middle term, and they do. So let's have a really brief review of factoring. Does that help a bit?
Yes, thank you.
You're welcome. Good question. Factoring, if you haven't done it in a long time. That's something that is not really a portion of this course. So if you need extra support on that, you might pull out a previous textbook or look online. Lots of great resources. What else? Any other questions?
I have a question. It's Julie. Can you go over number 36 on 3.2?
3.2, 36.
Thank you.
You're welcome. Alright, so that one is, oh man, I think I have that, oh maybe it's, I have it open in a window somewhere. I don't see it. There. 3.2, 36. Using snipping tool to copy it. Paste it here. And the directions are write the domain in the range and interval notation. So the domain. I'm going to look at how far left to how far right does this graph go. Now, when it goes to the left, let me zoom in a little bit here. It's -3 is halfway between -2 and -4 there, and it's not quite that far. It's -2.2, something like this. It's just a little bit to the left of -2. And since it's an open circle, I'm going to put a parenthesis. And then, so if I was like saying, what is the output if the input is -4? Well, it's not part of the domain. It doesn't strike the graph anywhere. And I have to be -2.2 or to the right of that. Now, how far right do I go? I'd be tempted to say about 3, but I notice this arrow means it goes forever. It's very clear that it goes infinitely high, but it's also leaking to the right. It's also going to go infinitely far to the right, so it's infinity. The range is on the y-axis. What are the possible outputs? The smallest is -4, and the largest, I'd be tempted to put 10 here, but how it goes, as long as there's any height that can be above this. Now, it's possible to get super large heights. So, Julie, does that answer your question for 36?
Yes, it does.
All right.
Thank you.
You're welcome. Other questions? All right, if no other questions, let's go to 3.3, rates of change and behavior of graphs. And this has to do with IBM stock. It starts on day 3 at $20 per share. So we can see that from the picture here. On day 3, that blue dot says it's $20 per share. On day 6, it is $41 per share. So the question is, how fast is the stock price? How fast is the stock increasing in price? And this is called the average rate of change. And so, I want you to make your best guess on this and type this into your group chat, but don't hit enter quite yet. How fast is the stock increasing in price? Is it going up at $5 a day or $20 a day? Or how fast is the stock going up in price? And very important, you have to put something. You can always put "I don't know" into your group chat, but again, you're going to get a lot more out of this class, even if you take wild guesses. Okay, go ahead and hit enter in your chat and discuss that briefly in your groups. Group leaders, you should have let each person know, in your group chat, you should have identified who's the group spokesman for the day. Otherwise, it'll fall on you when I look at my list. If I don't get a response, I'll ask the group leader. Okay, group 6. What do you got? You can always say pass as well.
I think Garrett was a spokesperson, but I'm not sure if his mic was working.
Okay.
But I guess none of us in our group really have an idea. I know, like by the time it hits 6, it's gonna be a little bit more than twice as much, but I'm not sure how to put that into an average rate of change.
But you had a basic observation that it more than doubled in price during this time interval. All right, that's a good start for us. More than doubled in price by the time it hit 6. Okay, thanks for that start. And let me go to group 1. Any ideas?
To be honest, I'm not too sure.
This one's kind of tough, isn't it?
Yeah, this one's pretty tough. I wouldn't really know how to answer it.
Okay, all right. Let me open the floor up to anybody. Anybody have any ideas? Is it going up maybe like $10 a day, or how do we tell?
$7 a day?
And how did you come up with $7 a day?
It goes up $21 over 3 days.
Look at. All right, so what we're seeing is if we go from here to here, how many days transpire? You're kind of making a right triangle on this when you do this. This is 3 days. And then we go up. Now this was a height of 20 and this was a height of 41. Subtract them. This is $21. It went up $21 in 3 days. So, and what the suggestion we have is divide those. And then the units will be dollars per day. You can change it from days to day, singular to plural, as needed. So how fast is the stock increasing in price? The average rate of change is $7 per day. Now, what that means also is if we were kind of going directly from here to here, every time we went over 1, we'd go up 7. It would be 27. We went over another one, we'd go up another 7. From 27 to like 34. And then over 1, go up another 7. Alright. Now, any questions? We'll move on. Alright. Suppose we have the same starting price. 20. Day 3 is $20. At day 6 is $41. But almost all the increase in price happened in the first day as shown. Zoomed up and then basically held steady. Find the average rate of change. So, in your group chat, make a guess. Let's do the average rate of change. And there's a little story about making a guess and how important that is. And I have 4 classes, so I'm going to ask if you've already heard this before. Please interrupt me so I don't just repeat myself. It had to do with research that was done in a college algebra class. Did I tell you about that 5 years after the class? Okay, so nobody's interrupting me, so I don't think I've told it so far then. 5 years after the class, these researchers identified two types of college algebra classes. One where they were always given an example and then asked to do stuff. And other types of classes, more like this class, where students were asked to make guesses and things all the time. And what they found that 5 years after the class, when they asked the student, here's a problem kind you might have seen in college algebra, can you still do it? And what happened was, when they'd always been given an example, the typical response was they wouldn't lift up their pencil. They said, oh, I used to know how to do that, and if you show me how to do it, I'll do it. But the other class tended to, students from the other type of class, picked up their pencil right away, mammothly worked on it, enjoyed working on it, may have been able to remember it, may have been able to reconstruct it, may not have, but it was a totally different approach. And what we value here at this school is that you enjoy math, that you engage in it, and that when you get out of this class, you feel like doing more of it rather than shying away from it. So that starts here by taking a risk and taking guesses. So go ahead and take a minute. And go ahead and hit enter in your group chat and give you a brief bit of time to look at other responses. Again, if you don't know anything, you still need to participate in the group chat and say I'm stuck or whatever. I'll be checking on group chats as part of your attendance participation grade. All right, group 2. What do you got?
Looks like it would just be 21, maybe.
Okay, and explain how you get that.
I'm not too sure.
All right, 21. Is that one of the responses in your group?
Yes, sir.
All right, excellent. Because that's all you really need to do is just say, this is what somebody in our group thinks it might be, 21. All right, and we did increase in price from $20 to $41, which is a price gain of $21. So this is going up $21. And this happens over 3 days. And the average rate of change, it turns out to be exactly the same answer. We're going to get exactly the same thing that we had over here. I'm going to see if I can just copy this. Let's try this lasso select. Yeah. See. Control V. And it's exactly the same answer. And what we are seeing is how the price actually went up is irrelevant to the average rate of change. When we were given no information how the price went from here to here, versus when we were given, it went up mostly in the first day, and it doesn't matter. Average rate of change assumes a straight line from one to another, and it winds up telling you if you went on a straight line from here to here, every time you went over 1 day, you'd go up $7. So that by the time you went over 3 days, you'd be up $21. Is that clear? Any questions? Alright. So that's just summarizing. It doesn't matter how you went. Let's go to the next. Find where f is increasing in this graph. And again, where a graph is increasing, where it's decreasing is something I'm going to define, but I want you to interact with this and make your best guess, even though you might not have any idea on this. Type it into your group chat, but don't hit enter quite yet. You could think of this as like a stock market curve if you wanted to.
Quick question. So, like, what are we trying to like do on this one?
You are trying to answer the question, find where f is increasing. And how you're going to describe that can really vary. So make your best effort, and I'll go through ways to describe it that'll be more clear than other ways. But we kind of want to see a bunch of different ways you might try to describe where is f increasing. Thanks for the question, because it's kind of hard to tell. What does he mean? Okay, go ahead and hit enter. Any description you have about where f is increasing. Okay, group 3. Any ideas here?
Someone in our group said that it was around x, the bracket 2 and 3, u 7 and infinity.
Kind of like this. Is that what you're describing?
Yes. Infinity and then the parentheses.
And then a parenthesis. Okay, so let's look at this in terms of find where f is increasing. And now I might say that, all right, if I bought stock in this company, and if I bought it right here, put a little X, I'd be happy until right here. From here to here, I'd be happy at first. And then, the price is falling, and I'm not so happy, so F is decreasing, my stock is going down. And I'd be sad until right about here. And then I'd be happy again. Alright, so there are two places where f appears to be increasing. Here and here. It's going up. But how in the world would you describe it? One way to describe it is verbally. Over kind of on the left side it's increasing, and way over on the right it is increasing again, and in the middle it's decreasing. But we need to be more precise in it. So another way you could describe is you could start to describe it with the heights. It's increasing when the height is between between y equals 4, see right here, up until like y equals 7. Would that be a good description of when it is increasing? If you say when the heights are between 4 and 7 is when it's increasing. Everybody agree that that's a perfectly good description? Or does anybody disagree?
Yes.
You agree? It's a good description? Great. Anybody
No,
else?
I'm just saying. I don't know.
Okay. It seems reasonable, doesn't it? Between a height of 4 and a height of 7, the function is increasing. But if we look at that a little bit differently, between a height of 4, we really should go all the way over here. And look at, even this part is happening between the height of 4 and 7. When you go between the heights of 4 and 7, you don't get just this portion of the graph, you also get this portion. And you're also going to get another portion, this little portion way over here. Alright, so we don't get a unique portion of the graph if we describe in terms of the height. But we will get a unique portion of the graph if we describe a different way. So let me use my small eraser. Get rid of these dotted lines. Okay, let's suppose we say increasing when x is between 2 and 3. Now this actually is guaranteed to give us just one portion of the graph. Why is this guaranteed to give us one portion of a graph? Because f is a function, and functions pass the vertical line test. Any vertical line will hit the graph at most once, and so you won't see, because if you had a stock market curve that looked like this, it would be nonsense, because at one day it would have 3 different closing prices for that stock. You never have that. You can't have that and be a function. So for functions, which is what we're going to be focusing on in the semester, functions will be, you'll get a unique portion, a single portion, and when x is between 2 and 3, and or when x is to the right of 7 over here. And this is exactly the answer that was stated for the group, which is, find out where f is increasing. We would say it's increasing here. Now this is the same as stating it this way. When x is between 2 and 3, or x is greater than or equal to 7. That's using inequalities. This is using interval notation. So we can state where a function is increasing by doing this. And the next task is find where f is decreasing. So let me give you a minute for where is f decreased. Okay, so because we're running short on time a little bit, this we would say decreasing colon from, again, along the x-axis. So from 3 out to 7. All right, and actually, I would, if I was going to get really technical, I won't really get fussy on this. These things should really be parentheses instead of that. And the equal signs should be gone. What's happening at 3 itself, it's not decreasing or it's not falling or rising, it's momentarily horizontal. The kind of like the tangent line would be horizontal. It's transitioning right at 3 from being increasing to decreasing. And right at 7, it's transitioning from decreasing to increasing. So right at the end point, it's neither of those is really happening. Alright, and let's go down to here. Find the average rate of change. Now, in order to get things done in time, I'm going to have to change the mode here. And I'm going to have to do these. Find the average rate of change from 2 points. This is very much like this problem way back. Between 2 points, whether we knew how it got there or not, finding the average rate of change means ignore how you got from one to the other and just look at that line. And the average rate of change is also the slope. Slope of the straight line. That's going to go from one to the other. Now, the slope is, call this the run. And this the rise. So the run is the difference in the x-coordinates. If you went from an x-coordinate of 1 to an x-coordinate of 3, you changed by going up 2 units. Excuse me. You can always find that by subtracting the 2 x-coordinates. The rise, subtract the heights. The upper height minus the lower height. We went 12. And the average rate of change is the slope of the straight line, which is the same as the rise over the run. 12 over 2, which is 6. And if we saw this like the stock market problem, we could think of it like this. If this was the day number, from day 1 to day 3, 2 days went by. The price went from $1 to $13 per share. And so it rose $12 in 2 days, $6 a day. Would be a possible interpretation of something like that. So average rate of change, that's what we were looking at way back up here. This caused us to make this triangle. Now we are getting these new insights. This was really a run. This was really a rise. And we wound up doing a rise over a run, which was the slope of this. And now, let's go to another problem. When you're presented with a table of values and you're asked the same question. So you just center these. And we're going to find the average rate of change once again. To find the average rate of change, if all you're given is 2 points in a table, average rate of change is the slope. Now, we're going to think of this as x sub 1, y sub 1. The subscript just means it's the first point, first x coordinate, first y coordinate. X sub 2, y sub 2. And the old-fashioned slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Slope, and this is the same as the rise, because it's the difference in the heights, on which the heights increase. So y2 is negative 4 minus y1, which is 3, over x2, which is negative 2, minus x1, which is negative 5. And this gives me negative 7, and the two negatives on the same number make that positive. So there's my slope, the same thing as my average rate of change. I might want to write that, and it's optional, but I might want to write that as a mixed number. Okay. So the slope of the line that goes through these 2 points is negative 2 1/3. And then, alright, let's want to find the average rate of change of this function on the interval 1 to 4. Now, this sometimes gets confusing when you see on 1 to 4. What does this 1 to 4 mean? It means x between 1 and 4. And that's the interval notation of writing that. Okay. So, what this means is, if we had a table, and all I need is the first point and the last point. And the average rate of change, although this is going to be a parabola, a downward parabola, we don't care about that. Average rate of change just looks at the endpoints and assumes a straight line and will tell you how fast things are rising or the slope. So 3 minus 1 squared, this is 2. 3 minus 4 squared is 3 minus 16, which is negative 13. Okay, so then the average rate of change is equal to the slope, which is equal to y2 minus y1 over x2 minus x1.
In the equation, it's supposed to be -3, or is that an equal sign?
I think it's an equal sign. Yeah, there's no -3 there. Okay. So -13 divided, hold on. Yeah, -13 minus 2 over 4 minus 1, -15 over 3, which is -5. So that's the average rate of change, or the slope, which is -5. Alright, now that is all that we needed to get to. This other stuff was some review stuff at the bottom. And so your homework is 3.3. And if we look at our schedule, the next time we get together on Monday, you're going to have a spot check on this 3.3. You have to have at least 75% of that uploaded. And then the 3.1 and 3.2 turn-in has to happen on that day, on Monday. And so it's the same problems that you had done in the spot check, but you have a chance to finish up every last one, make sure it's right, and upload it into 3.1 and 3.2. Any questions? All right, we will stop here and I'll stop the recording.